is Maniramakrishna. Now we'll go for the topic is this alternate. Here we are having the alternate topic. So here for the first electrical machine. So the machine which converts mechanical energy to electrical energy or vice versa. So either motor or generator depends upon the type of the energy conversion. Here alternator converts mechanical energy to electrical energy. It gives the AC output. So in this class we are going to learn about the principle of operation, construction details of the alternator, types of the alternators, parts of alternators, and types of the rotor and types of rotor stator slots. Here alternator works on the Faraday's laws of electromagnetic induction. So first law states that whenever a conductor cuts, the magnetic field changes and EMF is induced. Second law is the induced EMF directly proportional to the rate of change of flux. So here first law used for the motor generators of the DC as well as AC. So for the AC and DC generator we use the first law. Whenever the conductor cuts, the magnetic field changes, the EMF is induced for the DC machines as well as AC machines. Here the second law of Faraday's law, this will be used for the transformers. So transformer will having the rate of change of flux. So induce the EMF, we need three things. One is the conductor, rotating magnetic field, and relative motion. Here we are giving the alternator, we're having that. So alternator converts mechanical energy into the electrical energy. Here we are having the field winding and the stator winding, that is armature. Here before going to type, so first we'll go for the how EMF takes places. Yeah, here we can see that rotating coils will having. So here rotating magnetic field induced in the alternator. Here that's will form. So we are using that. So here when your rotating magnetic field is there, and here we're using the parts. Okay, we're having the rotor part, stator part, and this is the rotor which is having the silent pole, that is the projected pole, and field winding we're placing the stator, and it's the terminal box. Okay, this is about the construction details of the alternator, and it will go for the here the alternator and types of the alternators. We're having the rotating magnetic field. If we have the armature in the rotating magnetic field, and for the small machines this will be used, and for rotating field type this will be used for the large capacity machines. The parts of the machine which will have the stator part and the rotor. And the stator, we are having stator frame, stator winding, stator core, and the rotor, field poles and windings, shaft bearings, slip rings, brushes, and brush holder, spider, exciter. So this will come to the parts in the rotor. These are the parts in the stator. We will have the stator frame, stator core, shaft, stator winding. Okay. The rotor, we are having the field poles, windings, shaft, bearings, slip rings, brushes, holders, spider, etc. Here we have the parts which having shows that. So here spider ring will be placed, and the exciter which will have the excited by the DC source, and the brushes to the copper brushes will use, or copper brushes also be used. Here we have the rings, stator terminals, slots for the stator winding, that is open top slots here showing. And the end rings will having the at the top, and the cage winding will have the stator cage winding, and the stator frame which will be made of the iron core. Okay, so here construction detail will go for that. Here the stator frame, it is made of the cast iron. It gives a mechanical support to the machine. The stator core, it is made of this laminated silicon steel. It has slots and its inner periphery to accommodate the conductor. So we'll show the how stator frame, stator core is having the practically. Here with the stator core and with the rotor which will have that. So here winding is place this one having. So here is showing the how winding is places the. So winding will having that. The rotor winding will having the rotor, the high EMF is inducing showing. So you can observe the rotor parts. The coming to the stator parts. So I'll showing that. So here winding, here the three-phase star character windings will having the slots of the armature. That is the stator armature. It's the slot. The armature windings which are connected, the star connected, and all it will connect to the star. Here how EMF is inducing, I'm showing that. Okay, so whenever rotor conductors, okay, we're having the rotor having the magnetic field and stator in the armature conductor. Whenever the rotations take place with rotor, that magnetic field is induced in the air gap between the rotor and stator. The magnetic flux linkage is cuts by the stator winding, that is the armature, and EMF is inducing according to. So here that we state when having the three-phase winding which are connected the 120 degrees phase shift. That's why you're placing the EMF in this 120 degree phase shift. You are observe that. So here 120 degrees phase shift will have showing for three phases, for R phase, Y phase, and B phases. We'll have three phases winding. So here is showing the stator frame, the stator core. Now coming to the laminated. Okay, so here on the stator core is a laminated with the silicon steel to minimize the eddy current classes in the stator core. So in the stator core, in the front side view, we are seeing the air ducts. So in between the air ducts, we will show the air gap to cool down the armature conductors from overheating. So construction features will go for the laminations are made of the complete rings for smaller machines in segments to larger machine. Okay, the stampings have the opening and providing the cooling. Here we are alternative having the DC shunt our compound generator the excitation profiles for the rotor. This is the excitation of the is the alternator. Here we're having the generator, DC generator. So it will give the DC excitation to the rotor of the alternator. Here, so here the machine spots, the slots. So we're having the two types of slots, that is open type, semi type, three types of slots: open type, semi-closed type, and closed type. So the placing of the winding for the slots here it shows that. So the wide open here the slots will be placed there, and winding will place in between these slots. These are the laminated steel, silicon steel laminations, and the semi-closed type also windings there, and closed type here on the winding. Here open type slots we're having some disadvantages for the open type slots. We're having distributes the air gap flux into the top mist, produce ripples in the generated EMF. Here the comparison between the open type, semi-closed type. Here reluctance is more and medium, less for the open type having the more reluctance, semi-closed type medium, closed type having less, coil insertion removal having the more. For the open type, in the semi-closed type having the easy, and the closed type have the difficult to coil inertion, while replacing the coil winding of the field. The coil support for the open type having the less, and the semi-closed type having the more. For closed type having the more coil support. Here the stator winding. So at the conflict to the stator winding, that is the armature winding. The armature winding is the stator core slots. They are made of the copper, and also known as the armature. The rotor, the field excitation to the rotor is provided with the small DC shunt generator or compound generator. It is mounted in the same shaft of the alternator. So here is shown this. Here this is the DC shunt and compound generator, the same shaft of the motor. It is mounted on the same shaft of the alternator. The power rating is normally 0.3 to 1% the power rating of the alternator. So They have 100% alternator. The 1% of the DC shunt generator is used for the excitation of the alternator for the field windings. With the rotor, we have the two types of rotor. One is silent pole, another one is the non-silent pole or cylindrical type. So the silent pole, which I am showing the video, that is the projected pole. So here we are showing the projected pole type rotor. So this so we are showing this the projected pole type, and it's another type is called the cylindrical, smooth cylindrical type. So rotor, which is the silent pole rotor, which is the projected pole type, it's used for low and medium speed alternators. They use for small steel lamination riveted together and fixed to the rotor by dovetail joint. The pole faces are provided with the slots for damper windings. Silent pole rotor. The damper windings is used for prevent the hunting. The hunting is take place in between the rotor and the stator magnetic field to avoid the synchronization. So due to the magnetic locking will take places in primarily, so to avoid the magnetic locking, and that is the hunting. So to avoid that, we are going to using the damper winding for additional winding. The field coils are providing the pole faces, so they are connected series and connected as DC source through the slip rings. So here it shows the damper winding at the pole shoe, and here having the main winding place in between the windings. So at the sum of the special features of the silent pole type rotor, they have the large diameter, the short axial length, short pole. The pole shoes cover the about 2 by 3rd of the pole pitch, and they are employed in hydropower. So these silent pole rotor usually in the hydropower plant, like the low speed applications. And the non-silent pole, are coming to the non-silent pole, that is cylindrical pole type. They use for the thermal power plant as well as hydropower, nuclear power plants which have the high-speed alternator and the turbo generators which were used. The smooth cylindrical laminated core having the slots on its outer periphery from the field winding. So designed for the 2-pole machines having the 300 RPM, the 4-pole machine having the 1500 RPM, for 6-pole having the different RPMs for there. So the mainly cylindrical type machines are non-silent pole type having the 2-pole or 4-pole machine on the 1500 RPM and 3000 RPM, which have the highest speed of the motor generator type, based on the turbine type we are using. So there's an unsalted position from the pole faces. So this you can shoot the unsalted from the pole faces. We can do that. The field when you placing in between the slots. So pole area having the last type the whole area, and having the more type and the filter bar. Field winding is there, and the DC excitation will be through the brushes. So in the silent pole we are through the brushes, but here we are giving the directly to them from DC supplies given to the cylindrical type. Here we have some special features for the cylindrical type, having the small diameter and the large axial length. Due to that, it will be used for the higher speed applications, and the less winding is largest compared to the silent pole type. So it is for high speed applications and good balancing and quite in the operation. So these are the small differences between silent pole and non-silent pole type rotor. Having the number of poles and the more in the silent pole, and non-silent, that is cylindrical type, having the less poles. So the speed having the less for the silent pole, non-silent having the highest speed. Axial length is less, that's why using for the speed is less. Non-silent having the high speed, that's why used for the axial length is more. The diameter having the more, and here having the less usage for the hydropower plant and the thermal power plant. So this is about the construction and the working of the alternators. Thank you. I hope you understand the working and principle of the alternator. Okay, thank you. This is the Maniramakrishna signing off from the home. Thank you. Have a good day.